Hello and welcome to an Autodesk Simulation TV 2-minute tip. My name is James Herzing and we're going to be looking at the Bolt Wizard. When we open the Bolt Wizard, we're going to see that there are three main types that we can work with. A bolt with a nut, a bolt without a nut, or a grounded bolt, in the case where you have a bolt going into cement or some other object that's not going to move. After defining all of the other properties for this bolt, we're going to be able to define a preload, either an axial force or a torque. So let's jump over to the software and take a look at how this is actually done. So you can see here that we have two solid parts that we're going to be working with. So say these parts aren't bonded together, maybe they have surface contact, but we don't want them to move. Well, we can put a bolt in here to tie them together. Why don't we just do that in CAD? Well, then you bring over a bolt that has a whole bunch of elements, makes your model run a lot slower, and just imagine if the threading was modeled in there. I bet all of you are using that with the threading, right? Well, we don't want to do that. Okay, get rid of the solid bolt, and we're going to click on Mesh, and then Bolt. What we're going to do here is define the actual bolt using line elements instead of the CAD 3D. So first we need to define a part number in the top corner. Since 1 and 2 are already taken, we're going to go with number 3. Next we can choose the type of bolt that we're interested in. You can see there's 3 options. The one that has the most setup involved in it is the bolt with a nut. So we're going to choose that and then go down to the number of spokes. The number of spokes is how many places that the bolt is going to connect to the solid parts. By default that's 12. So from the center of the hole there are going to be 12 lines coming out to attach to the solid part. You can change that to be more. If you do, you're going to have smaller hot spots from any preload that you have applied to the bolt. Let's leave that at 12. The next thing we need to add, bolt diameter. The size of this hole happens to be 1 1/4 inches, so we'll type that in and move on to the bolt head. We're going to choose this surface on the front of our part as to where the bolt head is going to be placed. If we select it and click Add, you can see it show up. We then click on the head diameter and make that something larger than 1.25. So 1.75 will be an acceptable number. So next we need to select all the surfaces in this hole for both of the parts. So you can either use a circle select or a box select, or go through and click them one at a time if you really like to struggle. Click on the Add button and you can see that we have 2 surfaces now added. You can see that there is a checkbox over here where it says Tight Fit. We can choose that to act as if our bolt's threaded into the part, and by doing that we check the 2, we have it threaded in there. Last we need to apply the surface where the nut's going to be located. Obviously on the back of this part's where that goes. Select that surface, click Add, and we have it. Type in the nut diameter again, 1.75. And the last thing we have to do is apply a preload to our bolt. Do we need a preload? No. But in this one, let's just take a look at how it's done. So you can choose to have an axial force. So if we go over to magnitude, we can type in something like 867. And say you decide you don't want that, you can just click on the torque, and you can see it grays out the axial force, and now you can put something else in there. How about 5,039? All right, and then we'll click OK, and we're going to see that we have an axial force applied to the bolt that we have created with line elements. So if we click OK here, you can see it shows up. All of these blue dots are construction vertices that are going to force nodes to exist anywhere that there is a blue dot. So therefore, our line elements are going to connect to the solid elements. If we choose to generate a mesh, we're then going to see how all of our parts tie together. We're also going to see that preload already placed on the bolt that we have created. So what's this doing for us? Again, it gets rid of all of those 3D bolts that you've been creating with all the threading that you can't get to mesh successfully, or even if you do, take a long time to analyze. This has been a 2-minute tip. I hope you learned something. Get in touch with us if you have any questions. Thanks.